so now we're doing 2014 AB. This is question number 1, and I realized not all the question 1 was asked, but that's okay. Let's just go for all of it here. Okay, so grass clippings. I'm assuming you guys read the problem already. I'm going to dive into problem number A. Find the average rate of change of A of t over the interval 0 to 30 seconds. Indicate units of measures. Okay, so number 1, or letter A, the average rate of change over 0 to 30 seconds would simply be the amount at 30 seconds, right, minus the amount initial, A of 0, over the change in time, 30 minus 0. Okay, now this is a calculator problem, so we're just going to punch all that in your calculator. You probably need to set your equation, your first equation, A of t, in your calculator. I would do that first. This would be like your y1. You can do it y2 if you want. I probably use it as y1 because I'm probably going to use it again over and over in the problem. And then using the calculator, you're going to get negative 0.197, and this would be pounds per day. Okay? Let me just, I'm going to highlight the answer here. We'll use purple for my answer. Okay, letter B, find the value of A prime of 15 using correct units. Interpret the meaning of the value in the context of the problem. So if A sub t, or A of t, is the amount of grass clippings remaining in the bin, A prime would be the rate of that amount, whether it's decomposing or whether it's increasing. The problem already tells you it's going to be decomposing. You're not going to have an increasing grass clipping. It's not going to grow, right? It's decomposing, so the amount is going to decrease over time. So letter B, they want to actually find A prime of 15. Well, A prime of 15, I would take the derivative of my equation. Remember, this is a calculator. You're not going to do that by hand. And you can use a calculator to find the derivative, and then you're going to input 15 into the derivative to find out what A prime of 15 is. And you should get this right here, or this value, negative 0.164. Now you have to interpret this. So you can either put the rate at 15, what is that, 15 days is negative 0.164. But I think the better way of saying that is the amount of grass clippings in the bin is decreasing because of that negative, right? It is decreasing at this 0.164. So to interpret that, I would probably put something like the amount of grass clippings is decreasing because it's negative at a rate in this case, I'm going to put a positive 1.64 because I already used the word decreasing. You don't want to put you don't want to put decreasing at a negative rate. That's like a double negative. So we're going to put decreasing at this positive rate, and of course our units, pounds per day, at a specific day, what t equals 15 days, right? So that would be the interpretation of A prime of 15. Okay, so continue on to letter C. We got find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass. Okay, so we're going to use our amount of grass clippings formula, which is A of t. And I'm going to set it equal to the average amount of grass clippings over 0 to 30 days. I want this to equal to 1 over 30, that's 1 over 30 minus 0, from 0 to 30, A sub of t dt. This is your average amount of grass clippings over from 0 to 30 days. And again, this is a calculator. We're going to punch all this in our calculator, and you're going to figure out what T is. And just to clarify that, you get just to clarify a little bit more, I think some students had trouble with this part in the calculator. I'm assuming that's why someone asked this question. This again from the beginning, this A of t, this was my y1, okay? And then this new equation here, this is my y2, which is going to be technically the integration of y1, right? You can include that 1 over 30 if you want when you input that into y2. But this is the integration of y1 from 0 to 30. And to find out where these two graphs intersect, right, you're going to use a second trace function on your TI, if you're using TI. Second trace and then intersect, right, on your calculator and figure out where they intersect. And once you do that, you're going to get t equals to 12415 days. Okay, this is yep, find the time t when it intersects and stuff. Okay, moving on to D. Looks like I ran out of space. I'm going to squeeze in right here. I'm just going to zoom in all the way to get right a little bit small here. This is going to be letter D right here. For t greater than 30, L of t, linear approximation. Oh, find the linear approximation. Okay, cool. So we're looking for an equation of a line, which I'm going to use slope-intercept form. 2a at t equals 30, right? And that's going to represent L of t. So I have, using this structure, y minus y1 equals m x minus x1, and we can change that. You can move that y1 over by adding it to both sides. So essentially you have y equals y1 plus my slope and then x minus x1. Now in terms of this problem, well, my y is my L of t. So I have L of t equals to y1 would be at 30 seconds, what is the amount? So I'm going to use a of 30 plus my slope at 30, so that's going to be a1 or a prime of 30. And then my x minus x1, my x is t, that's time. And x1 would be all the way to 30, right? 30 days. Okay, so this is my equation. And then you can find a prime of 30 in your calculator. You can find a of 30 in your calculator. So you can essentially have this, a of 30, I believe in the calculator is going to be like 0.782928. You're going to use a storing feature in your calculator. And a prime of 30 is going to be negative 0.055976. Again, use a storing feature in the calculator. Okay. And I went a little bit ahead. This first part right here, this right here is your linear approximation. Okay, I believe you get the two points right there off the bat for that. My next part, as I was going to do, was me actually finding out when will there be 0.5 pounds of grass, right? So I'm going to substitute this guy in for 0.5 pounds of grass, and then solve for t. And then I believe you'll get t equals to 35.0454, and this should be in days, right?